Welcome to my channel Priyanka's Learn It Well. In today's episode, I'll be covering Infix to Prefix with the data structure and algorithm series. It is in continuation with Infix to Postfix operation as taken up with the previous episode. If you're liking my content, do not forget to like, share, and subscribe. Let's start with today's episode. Before we start converting infix to prefix expression, it is very important to watch the conversion of infix to postfix expression. The link to the video is shared in the description box. Let's discuss the steps to convert infix to prefix. The first point is we need to first reverse the infix expression as given. So let's say a plus b star c will become c cross b plus a on reversing. Then the second important step is that we need to calculate the postfix expression in the same manner as discussed in the previous episode. The postfix expression that we will receive for a plus b star c is cb star a plus. The postfix expression that we get with the last step, we need to reverse the postfix expression to obtain the prefix expression for the given infix expression. It will be more clear when we'll take up an example. Let's have a quick recap for converting infix to postfix expression. Recapitulating on the steps to convert infix to postfix. First, we need to scan the infix string from left to right. So the scanning of characters is from left to right. We need to initialize an empty stack. Then we need to watch out for the character if it is an operand or it is an operator. We have already discussed what is an operand and an operator in the previous episode. If the scanned character is an operand, we add it to the postfix string directly. And if the scanned character is an operator, we would watch out for two conditions. If the stack is empty, we push the character to the stack. If the scanned character is an operand and we need to compare the precedence of the character with the element on top of the stack. If top stack has higher precedence over the scanned current character, we need to pop the stack, else we need to push the scanned character to the stack. We need to repeat this step until the stack is not empty and top of the stack has precedence over the character. Let's start solving an example to understand the process of infix to prefix clearly using the steps of converting infix to postfix. Let us now convert the infix expression to the prefix expression. Here you can see that there are three major steps to convert infix to prefix. The first step says that we need to reverse the infix expression. Then we need to calculate the equivalent postfix expression of the modified infix expression. And the last step is that whatever postfix expression we have gained, we need to reverse it back again to gain the prefix representation of the infix expression. So let's start with the evaluation. So the first step says that we need to reverse the infix expression. We have been given this expression. Now we need to reverse this. So let's reverse this string. So on reversing, what we will be getting is, so we start from here. So E minus, here one thing to be noticed is that while reversing the change, we need to change the open parenthesis to closed parenthesis and vice versa. So here, since it's a closed parenthesis, it become an open parenthesis. D plus C, the open parenthesis becomes the closed parenthesis minus B divided by A. So now we have successfully reversed the infix expression and we have received a modified infix expression. Now the second step says that we need to calculate the equivalent postfix expression using the rules that we have done in the previous episode as well. We have summarized it in the previous slides as well. So let's start with the postfix evaluation. So we start the scanning from left to right. So the first element to be scanned is E. Since E is an operand, it will be directly pushed on to the prefix string. Now here I wouldn't call this as a prefix, it is a postfix string since we are converting. So I'll just change this to postfix. So we will be directly pushing it onto the postfix string, and we need to declare the stack as empty. So since we do not have anything in the stack. Now moving on to the next part, that is the next character is minus. Since minus is an operator, we need to push it onto the stack since it is empty. So we will be pushing the operator onto the stack, the postfix string remaining the same. We know that parenthesis, so we have scan till here. The next character is a parenthesis. We know that whenever we encounter an open parenthesis, we directly push it onto the stack. So we have pushed it onto the stack with the string remaining the same. The next character to be scanned is D. Since D is an operand, it will be directly pushed on to the postfix string. So I will get ED. Then I have the character as an operator plus. We need to compare when the stack is not empty. We compare the scanned character to the top of the stack. Since we have parentheses on top, we do not have any precedence here. So we will directly push plus onto the stack with the postfix string remaining the same. Now we'll be so we have scanned till here. The next character to be scanned is an operand. So C is an operand, and we know that whenever we see an operand, we directly push it onto the string. So we get EDC. Now the next character is a closing parenthesis. We have discussed in the previous episode that whenever we have a closing parenthesis, we push it onto the stack, and whatever element is between the opening and closing parenthesis, we pop it from the stack and add it to the postfix string. So here we'll get EDC plus, right? Now let's move on to the next character, that is minus. So minus, so we have minus already in the stack, and since they are of the same precedence, I'll directly push minus again onto the stack with the postfix string remaining the same. Let's come to the next the character, that is B. B being an operand, we directly push it onto the postfix string, so it will be EDC plus B. Now let's come to the next character, that is a division operator. Now we need to compare the precedence of the scanned character with the top of the stack. Now the top of the stack has a minus. Since the precedence of top of the stack is less than that of the scanned character, we will directly push the division operator onto the stack with the postfix string remaining the same. Let's come to the next character, that is A. Now we know that A is an operand, and we directly push it onto the postfix string. So in the stack we have minus minus divide, and here we have EDC plus B, and we'll push the operand onto the stack. Now here we have reached the end of the expression, so we will be popping the stack in the same order in which it has been pushed. So we would be getting the string as EDC plus BA divide, and then we pop minus EDC plus BA divide minus, and EDC plus BA divide minus minus. So by at this particular step, we have completed the second step of converting the infix to the prefix. The last step says that whatever postfix expression we have received, we need to reverse it back again. So the postfix, so I'll just write down. So the postfix expression that I have received here is EDC plus BA divide minus minus, and when I have to convert it into prefix, I just need to convert it as reversion, that is minus minus divide A B plus C D E. Now this becomes the prefix expression of the given infix expression. Summarizing the steps of converting an infix expression to prefix expression, the first step is reverse the infix expression. Second is we need to calculate the equivalent postfix expression. And the third is we reverse the postfix expression to receive the final prefix expression for the given infix expression. Thank you for keeping up with my channel. That is all from today's episode. For more episode, please subscribe to my channel Priyanka's Learn It Well.